And today's discussion is what you mean by a random variable, what you mean by a random process, and what you mean by a continuous and a discrete random variables. These three topics will be covered in today's class. I repeat, first we'll see what you mean by a random process, later what you mean by a random variable, finally what you mean by a continuous and a discrete random variables will be discussed in today's class. Right? So this is what the module 1 complete syllabus. So today we will see the three topics. So cumulative distribution function and probability mass functions will be discussed in further classes. Alright? So what is random experiment? What is random experiment? So simple definition I will read here. It is an experiment or a process for which the outcome cannot be predicted with certainty. Alright? Let us see the one more definition. A random experiment, it is an action that produces a non-deterministic outcomes. Let us understand the random experiment with an example here. So we have said here, so output cannot be predicted and the output will be non-deterministic. Let us give a final touch to these two words. Take an example here. Before rolling a die, you do not know the result. This is an example of a random experiment. Roll a die. Rolling a die, the die has 6 spaces. These are given with a number. That number is varying from 1 to 6. When it is thrown, output is unknown. Then what will be the output? That is called as here a non-deterministic. Before throwing the dice, the output cannot be predicted. If that is the case, means that is called a experiment. Then one more example, tossing a coin, you have a confusion. The output, the result may be either head or a tail. If that is the case, means it is called as a random experiment. So random ways gives a non-deterministic outcome, or else the outcome of the experiment cannot be predicted. If that is the case, means that process, that experiment is called random experiment. Sample space. I will read the definition of it. The totality of all possible outcomes from the experiment. I have said we have discussed the meaning of a random experiment here. The total outcome of any random experiment is called as a sample space here. What are the total outcome of the dice, throwing a dice? There are 6, the numbers varying from 1 to 6. Outcomes 1, 2, 3, 4, 5, 6. That is the sample space of random experiment. We'll see the one more definition. A sample space, it is always denoted with a capital S. A sample space of a random experiment is the set of all possible outcomes. Hope you have understood the meaning of a random experiment and a sample space. When a dice is thrown, what is the sample space of it? Before throwing, before conducting the experiment, what is the sample space of throwing a dice? It is a set of the numbers varying from 1 to 6. Now, what is the sample space of tossing a coin? It is a set of either head or tail. Head and tail, it is a sample space of tossing a coin. To 6. It is the sample space of rolling a dice. So sample space in general, it is a complete all possible outcomes. That is called as a sample space here. Right? We'll see examples. The first example, tossing a coin. It is a random experiment, a random process, because when before tossing the coin, you do not know the outcome. There are two possibilities. The outcome may be head or outcome may be the tail. Outcome is non-deterministic, or else outcome is out outcome cannot. That's why tossing a coin is called as a random process or a random experiment. So random experiment is a tossing a coin. Then what is the sample space of it? The sample space of tossing a coin is a set of heads and tails. So in simplification, or in simple, a set of H and T. Consider the one more example. Throwing a dice or rolling a dice. It is called as a random experiment because outcome cannot be predicted. Outcome can be one among 6 possibilities, that is varying from the number 1 to 6. So that it is called as a random experiment. What is sample space of it? All possible outcomes. A totaling of the all possible outcome of any random experiment, it is called as a sample space. So the sample space of throwing a dice number 1 to 6. Right? Let us consider the one more example. A football, a game. It is called as a random experiment because we don't know when goal will happen. We don't know how many goal will be achieved. Don't know who will set the goal. That's why it is called as a random experiment where outcomes cannot be predicted. They are non-deterministic. So a soccer match or a football match, it is called as a random experiment where the number of goals which are achieved, they are non-deterministic. They cannot be predicted. It may be 0, 1, 2, 3 and so on. That's why it is called as a random experiment. Let us take one technical example. We'll talk more technically regarding the random experiment. A random experiment is considered here. Send a voice message over the telephone system. It is what one, or it is a process, and let us call we can treat this as a random experiment because of the following reasons. What is the task? The task is sending the voice SMS over the telephone system. Then it is considered as a random experiment because a voice can be anything. It may be a child voice, adult male voice, adult female voice. It may be a aged person voice. It may be anything. So that because of this statement, we can classify this statement as a random experiment. So why it is called as a random experiment? An outcome would then be a one of many possible voice messages. That's why it is called as a random experiment. Let us designate the collection of all possible outcomes from the random experiment as a sample space. What are the sample space here? What would be the sample space of this random process? All possible voice SMS sent by the different varieties of people. That would be the a sample space of this random experiment. It may be anything. It is infinite. Here the simple statement send a voice SMS over the telephone system. For that n number of possibilities are there. So that what is sample space for this random experiment is all possible voice SMS sent by the people. Right? Then each outcome is an element of S. That is what is the meaning of this statement? So a person the voice will send the voice SMS and it will be the element of a so let us consider one event here. The event A is considered. Event A is defined as all voice SMSs sent by the only adult male. So among this process, in this process, we have considered one event. What is that event? It is denoted with an capital A and it is defined as consider the voice SMS sent by the only adult male. Alright. Let us consider the one more event. It is defined with the capital letter B and it is defined as collect the voice SMS sent by the only adult female. Consider the one more event. It is defined with the capital letter C, and in this event we are collecting the voice SMS sent by the children. Alright, now the question is it true for this? What is that true? A is a subset of S, B is a subset of S, C is a subset of S. It is absolutely right, because S is a sample space. It is possible outcomes. Yes is a sample space, and it is having all possible outcomes of this random experiment. Among this random experiment, among this sample space, we are segregating the things. The things are segregated as A, B, C, where A is having only the voice SMS of the adult male, B is having the voice SMS of the adult female, and C is voice SMS of the children. Then, and we have given here the conclusion as A is a subset of S, B is a subset of S, and C is a subset of S. So it is what one technical example for a random experiment, and a random experiment, and a definition of samples. B, here three words are explained: random experiment or random process, a sample space, and the event. In case of tossing a coin, the first event is getting heads, one more event is getting tail. In the case of throwing a dice, an event may be anything. The first event may be getting odd numbers, it may be one event. Getting even numbers, it may be a second event. And getting the sum of numbers which is less than 2 or less than, they are events. Always events are a subset of a sample space. Conclusion is events are always a subset of a sample space. Right? Good. We go ahead then. What is a random variable? We have seen a random process or random experiment. We have seen the sample space. The next concept is, what do you mean by a random variable? I do read the definition of it. A random variable is a function that assigns a real number called as an observation to each outcomes in S. What is S here? S is a sample. A random variable assigns real numbers to the outcomes of a sample space. It's a simple definition. A random variable which assigns a real number to each outcomes in the sample space. What is outcome here? Outcome. Tossing a coins, outcomes are head and tail. Throwing dice, what are outcomes? Numbers from 1 to 6. Right? So they are called as an outcomes. Assigning a real numbers to each outcomes, it is called as a random variable here. Right? So it is denoted as capital X is a random variable, A is an event, XA is a real number. So it can be read as XA is a real number assigned to the an outcome A of the random experiment. I repeat here, XA is a real number which is assigned to outcome A using a random variable, a capital X. Alright, it's a simple definition of a random variable. Then a domain of the random variable X is all outcomes such as A in the S. The domain of a random variable X is all sample spaces, means all outcomes in a sample space. Now, and its range is all observations such as XA that are in SX. We'll come to know what you mean by S, then what is the difference of what is SX and what is S, then what are the difference. That will be discussed with the examples in next slides. In these slides, you have to understand the meaning of a random variable. Random variable which assigns real numbers to the outcomes of the sample space. It's a simple definition. Then it can be defined as XA equals to XA. capital X is a random variable. Capital X is a random variable. Then small a is a outcome in a sample space. XA, it is called as a real number which is assigned to the outcome A of the sample space. Alright. Now, it is also called as a single random variable because it produces a single observations. Alright. So, we will come to know. So, each real number is assigned to outcome A and it is a 1-to-1 ratio. That's why it is called as a single random variable. Fine. Okay. You may use U, V and any capital letters. Any capital letters are used to define the random variable. All right. So just in this slide, the only thing you should understand is a definition of a random variable, which assigns the real numbers to the all the samples of all the sample space. All right. One statement is written here. A random variable allows us to transfer our attention from the physical entities in a random experiment to an associated set of observations, that is a real numbers. I will tell you. So random variable which transfers a physical entity into a observation. Tossing a coin is a physical entity. Then a betting, providing the amount or issuing the amount is the observation. Then throwing the dice is the a physical process. It is a physical entity. Then for all 6 numbers, we are providing some few experiments, some few observations, we are assigning some real numbers that are stored in SX. Hope all of you have understood it. What is the difference between capital S is capital S is a sample space. Capital SX is a real numbers which are available in real numbers which are assigned to the sample space. All right. So let us understand that concept in more detail. So S is a sample space where we have outcomes as a head and a tail. It is the outcome of a tossing a coin. Then what is random variable? Random variable assigns real numbers to these outcomes. Random variable which assigns real numbers to these outcomes. So that it may be either -1 or 1, it may be 100, 200, or it may be anything. We are assigning any real numbers to these head and tail. So it may be if head is the result, I may give 1,000 rupees to one of my friend, or 2,000 rupees to the friend number B, and so on. It may be anything. It may be any random. It may be so number. So assigning these are the physical quantities and these are the real numbers. So a random variable which transfers one form of entity into the another form of entity. So that's why a random variable which assigns real numbers to the outcomes of the random experiment. All right. So let us discuss here a few more definitions or few more concepts of the S and SX. Head and tail are the possibilities after tossing a coin. Then what is the probability of the head and tail? It is 50%, right? So if head appears, I will assign the +1. If tail appears, then I will assign the -1. It is the task of the random variable. So instead of +1 and -1, I will assign a zeros and 1. Not an issue. It may be anything. A random variable is X. If head appears, it is assigning a 0. If tail appears, it is assigning the 1. Then if head appears, it assigns the 1. If tail appears, it assigns the 0. So it may be anything based on the requirement. All right. So this is called as a random variable which transfers which process from one form into the another form. All right. So one more thing here, a random variable, a numerical value to each outcome of a particular event or a particular experiment. One more definition, a numerical value is assigned to each outcome of a particular. This rectangle, it is a sample space S where 1, 2, 3, 4, 5, 6, 7, 8. Here 8 available. To these 8 outcomes, we are assigning the real values. And it is S and it is Sx. It is S, it is what? S and it is Sx. So these are the events of any experiment. These are the events. To these events, we are assigning real values. We are assigning the real numbers. It is the task of the random variable X. It may be either capital X, capital V, capital A, or it may be anything. So I repeat here, it is a sample space where we do have 8 outcomes. To these 8 outcomes, we are assigning the real numbers. The range of Sx, is from, let us take it as a -5, and let us take this as a +5. It may be anything. So for simplicity, I have taken this as a +5 and this is a -5. So range of Sx is varying from +5 to -5, and real values are assigned to the outcomes of the sample space. Right? So let us take the one more example here. One more example. This square is a sample space where three outcomes are available. To these 3 outcomes, we are assigning real numbers. Instead of numbers, we are giving XA, XB. So what is this? It is the range of Sx. What is this Sx? Sx consists of sets which are in accordance with the outcome of the sample space S. Right? So here random variable X is used here, which assigns the real numbers to the outcomes of the sample space. So what are A, B, C? They are sample spaces, outcomes of the sample space. What are these XA, XB, XC? These are real numbers. They are in the line of X. Then a random variable, it is called as a many-to-one function because XB real number is assigned to the 2 outcomes of the sample space. B is the outcome, C is also an outcome. B and C, we are assigning the same real number. That's why, so real number is in general called as a many-to-one function. All right, this is because many physical outcomes to have the same observed value. All right. AS here. What is AS here? A physical identifiable outcome of a random experiment means getting head or tail, getting number 1, 2, 3, 4, 5, 6 of the dice. What is Sx? Assigning the real numbers to that head and tail 1, 2, or 1, 2, 3, 4, 5, 6. Then what is X here? Outcome, and it is independent. Getting head is independent. Getting number 6 in the dice, it is independent. Okay. So let us consider real-time examples. Real-time examples which gives Sx and S. A noise, antenna and link, a noise and link, or the elements of the sample. Then measured average power of each n of t is a real number. So we are assigning average power to the noise, and it is in Sx. We will get the noise, that is the yes, we average observing average, we are assigning average power to the each noise, that is a real number, that will be in the Sx. Consider the manufacturer products in use and servicing the customers, they are in the sample space S. All right, we do purchase the bike or a car. So how many bikes or cars are purchased, that will be in the sample space S. What is observation? Fails when it time to failure of the each product, when they do come for the service, then for how much, for how long it works properly. That's the observation for that delivering the bikes. So that products are available in the sample space. For those products we are providing some measurements that will be there in the SX. So consider transistors which are manufactured with the different groups and types. Let us store them in a sample space. All possible outcomes are there in the sample space. Then what is the measured maximum switching speed at which each transistors can operate, that are observed and which are stored in the ASX, right? So one more, the last example, which is related to the queues. Computers queues are stored in the ASX. Then at particular time interval, how many queues are available? All computers queues are stored in the sample space. Then take any point of time, take any time interval. At particular time interval, a number of queues are available in the program. So that is called, that is stored in a SX here. Simple thing. Random variable which assigns the real numbers to the outcomes of the sample space. What are outcomes? Or possible outputs. Why it is random process? Because output cannot be predicted. Our output is non-deterministic. What is sample space? All possible outcomes. What is event? So event, in case of tossing a coin, getting heads. In case of throwing a dice, getting even numbers, getting odd numbers. They are the events. Always events are the subset of a sample space. All right. There are two types of random variables, discrete random variables and continuous random variables. So what do you mean by continuous random variable? If a random variable takes on any value in a whole observation interval, X is called as a continuous random variable. The example, the noise voltage generated by the electronic amplifier has a therefore the sample space S of the noise voltage amplitude. So a random variable has continuous range of, in your mind, keep that point in your mind. So continuous variable has continuous range of values. So the random variable takes uncountable number of possible values. It is just you think you know the meaning of continuous. Then let us apply that concept to the random variable. Then discrete random variable. A random variable X is a discrete. X can be finite number of values. It takes only finite number of values. So that a discrete random variable has a countable number of discrete values. Alright. So today we have discussed a definition of a random variable, random process, a sample space, event, outcome, then types of the random variable.